Hello everyone, this is Aditya and I hope so that you are doing great, and today we'll discuss about digamma function. But before starting with this lecture, I want you all to first of all recall what is gamma function. If you haven't studied about gamma function, then just watch my one shot on integral calculus. In that I have discussed about gamma function and beta function, right? So in that you can study about those things. I will give the link in description or in comments, right? Okay. So now let's recall what is gamma function. So gamma of n, so it is equal to n minus 1 factorial, right? Okay, this is the basic definition of gamma function, right? So suppose if I ask find gamma of 2, it is equal to 2 minus 1 factorial, which is equal to 1 factorial, which is equal to 1, correct? Similarly, if I ask you find gamma of 4, it will be equal to 3 factorial, that is 6, and so on and so forth, right? So then what is special about gamma function? Because we all know that this is n factorial. We already know that n factorial is equal to n times n minus 1 till 3 into 2 into 1, right? We know that n factorial is this term, right? Or you can write it in product form also. The summation from I is equal to 1 to n of I, right? So the product from 1 is equal to n, right? Okay. So why do we require this gamma function? Well, if I ask you what is gamma of 3 by 2, or if I ask what is gamma of 1 by 2, that is what is 1 by 2 factorial or negative 1 by 2 factorial, and so on and so forth. Now you all might be thinking that how can we define factorials for fractional values? Because you all have been taught that factorials are basically used to find the arrangements or dearrangements or many other things like that. You must have studied about it in permutations, combinations, right? So how can we even think of that we can find the factorial of a fractional value? Well, the first thing is that which I want you all to do is forget the previous idea. Stop thinking factorial as arrangements. That is, factorials is not merely about arrangements. Think factorials which were used in permutation combinations as just one of the applications of factorials or gamma function. Actually, factorial is defined as gamma of n, right? Factorial n minus 1 factorial, or if I say about n factorial, then it will be gamma of n plus 1. So this is the idea of this is the basic definition of a factorial. Now, which you are studying over here is that it is the special case of factorials in which we find the factorial of only natural numbers, or sometimes we find the factorial of 0 factorial, that is sometimes find the factorial of 0 which is equal to 1, right? So that was a special case of factorials. Now gamma of n plus 1 is actually defined as integral from 0 to infinity t raised to power n e to the power negative t dt, and I have already discussed its proof in integral calculus video or in some other separate video you can check out in my channel, right? So this is the definition, the actual definition of gamma of n plus 1, that is n factorial is given as the integral from 0 to infinity t raised to power n e to the power negative t dt. So from now, remember factorial as a function, not merely as the arrangements, right? So from now, factorial, you should see factorial as function, right? And I think so that it should be taught like that only. That first of all, see factorial as a function and then use it in permutation combination. But we are taught in different way, just opposite way actually. But that's the problem which I can't solve. It's not in my hands. So I can tell you what is right or what is wrong. So n factorial is like this. So it is true for n belonging to real number, and of course not for all real numbers, because if you take suppose n is equal to negative 1, negative 1 factorial is not defined, okay, and so on and so forth. So minus some set a for which this is not defined, okay. So I will not define a for now, but it is not valid for all real numbers, okay. So this is the basic idea of gamma function, and for more detailed video. You should check that integral calculus video. Okay. So let me erase this, and now let's discuss about digamma function. Now I have told you all that gamma of n is equal to n minus 1 factorial. So it will be equal to integral from 0 to infinity t raised to power n minus 1 e to the power negative t dt, right? Okay. So now let's calculate this integral if n belongs to natural number. Okay. So gamma, suppose now I am naming it as, suppose okay, suppose I am now calculating gamma of x. So it is equal to x minus 1 factorial integral from 0 to infinity t raised to power x minus 1 e to the power negative t dt, right? Again x belongs to natural number. We are calculating it for a natural number for now, right? Okay. Now you all know a definition of e to the power negative t. What is the definition? It is the limit as n tends towards infinity. That is why I changed n. That was changed from n to x over here, because I needed n over here also, right? Limit as n tends towards infinity 1 minus t by n raised to the power n. Correct? You can evaluate this limit yourself, right? Okay. So this is the case. So now we have this is equal to integral from 0 to infinity, or I can write it as limit as n tends towards infinity 0 to n t raised to power x minus 1 1 minus t by n dt, right? Okay. So now how can we express it further? Well, we can use a substitution over here. T by n we can write as suppose we assume t is equal to some ny, right? Okay. So we will get dt as n dy, correct? So gamma of x will be equal to limit n tends towards infinity integral from when t is equal to 0, y is equal to 0. When t is equal to n, then we have y is equal to 1, correct? 0 to 1 of the quantity, what is t? T is equal to ny raised to the power x minus 1 times the quantity 1 minus, when you substitute t as ny, it will be 1 minus y raised to the power n dt, right? Okay. So you will get it as limit as n tends towards infinity n raised to the power x minus 1, and here we will have an n also, so it will become n raised to the power x times the quantity 0 to 1 of the quantity y raised to the power x minus 1 times 1 minus y raised to the power n dt. Sorry, dy. It will be dy, correct? Now if you have studied about beta function, you must be well acquainted with such kind of expression. Beta of m comma n is equal to the integral from 0 to 1 x raised to power m minus 1 1 minus x raised to power n minus 1 dx, correct? So over here this is beta of x comma n plus 1, correct? So this is equal to, so gamma of x turns out to be limit as n tends towards infinity of the quantity n raised to the power x beta of x comma n plus 1. Okay. Now just remember this expression. Let me erase this. So we had got gamma of x is limit as n tends towards infinity of the quantity n raised to the power x times beta of what we had got. We had got x comma n plus 1, correct? I hope so that we had got this expression only. We had x minus 1, yeah, we had got x over here. Now if you remember, beta of m comma n was also equal to gamma of m, gamma at n divided by gamma of m plus n, correct? Okay, just apply this identity over here. So you will get limit as n tends towards infinity n raised to the power x times this quantity x minus 1 factorial, that is gamma of x will be x factorial, x minus 1 factorial, and gamma of n plus 1 will be n factorial divided by x plus n plus 1, that is x plus n plus 1 minus 1, that is x plus n factorial, right? And from our assumption for x belonging to natural numbers, we can clearly say that this will be equal to limit as n tends towards infinity n raised to power x x minus 1 factorial times n factorial divided by the quantity x plus n times x plus n minus 1 till the quantity x into x minus 1 factorial, correct? Okay, and this will get cancelled, right? And of course, even if x does not belong to natural number, then also this case is true. Why? Because suppose gamma of 5 by 2 divided by gamma of 3 by 2. So I can write it as gamma 3 by 2 into gamma of 3 by 2, 1 by 2 gamma of 1 by 2, correct? Or let's leave it like that only, gamma of 3 by 2. So this and this will get cancelled, we'll get 3 by 2. So it's not necessary, but just for simplification so that you all don't get confused, I am assuming as x belongs to natural number, but this is not necessary at all. Okay, so you can remove this condition also, it's not necessary. So you will get limit as n tends towards infinity n raised to power x times n factorial divided by the product from I is equal to 1 or 0 to n x plus I, correct? So this is another definition of gamma of x. Okay, so just remember this. But why am I teaching you this? I need to teach you all digamma function. So for that this is required. So that is why I am teaching you. Okay, now let's erase this and let's see further. Now just remember this result. Limit as n tends towards infinity of the quantity n raised to power x n factorial divided by n plus x till x is equal to gamma of x, right? Just remember this thing. Okay, so let's erase this. Now let me introduce you all to digamma function. Digamma function. Okay, so digamma function is actually let me introduce you all. Digamma function, suppose digamma of x, how we define it? So this is how you write digamma of x, right? So suppose you have the gamma function gamma of x. Okay, you take the natural log of gamma of x, right, and you differentiate it. You will get gamma dash of x divided by gamma of x, right? Where the chain rule? Suppose if you have ln of x square plus 1, you take its derivative, what you will get? You will get, first of all you will differentiate this, you will get x square plus 1, and then you will differentiate the inner term 2x, right? So that is the case over here. First of all you differentiated with respect to ln x, so you got, you differentiated this function, you got 1 upon gamma of x, and then you differentiated this term, okay? So you got gamma dash of x. So this expression is psi of x, that is digamma of x, right? So it is basically used to find the derivative of gamma of x, right? Okay, so now we should write this expression also over here. So psi of x is the derivative divided by this term, right? Okay, so this is the basic definition of psi of x. Okay, but how can we evaluate it for different values? Now that is the question. I have defined the digamma function. Now how we evaluate this, that is the question. So let's understand that now. So you all must be knowing a result that gamma of x plus 1 is equal to x times gamma of x. 3 factorial is equal to 3 into 2 factorial. What is 3 factorial? It is gamma of 4. What is 3? 3 is 3. This is gamma of 3, correct? Okay, so this is 3 plus 1, so 3 over here and 3 over here, right? Okay, so you have this expression, or n factorial is equal to n into n minus 1 factorial, right? That is what I am applying over here. Okay, so gamma of x plus 1 is equal to this quantity. Let's take natural log both sides. Okay, so you'll get natural log of gamma of x plus 1 is equal to ln x plus ln of gamma of x, correct? Now just differentiate both sides. What you'll get? We'll get just evaluate it. It will 1 by x plus this quantity. Are you able to follow it? The derivative of natural log of any quantity will be given like this. I told in previous part using that example of 2 of x square, natural log of x square plus 1, right? So that is what I have done over here. Okay. Okay. Now this is psi of x plus 1. This is 1 upon x. This plus psi of x, right? Okay. Now in this video, I'll be teaching you how to find the Digamma value, Digamma function value at natural numbers. Okay, so let's see how we can calculate it. So we have got this expression. So we have to remember this thing. Okay, so psi of x plus 1 is 1 by x plus psi of x, correct? Okay, now let's erase this and let's see how we can evaluate this thing. So we had got this is psi of x plus 1 is 1 upon x plus psi of x, correct? So how can we evaluate this? Means how can we separate psi from here? Well, you can say it as psi, just a minute, psi of x plus 1 minus psi of x is equal to 1 upon x. Wait, let me change the chalk. So you have got this expression. Okay, so when x is equal to 1, it will be psi of 2 minus psi of 1 is equal to 1 by 1, correct? When when x is equal to 2, it will be 3 minus psi of 2, 1 by 2, psi of 4 minus psi of 3, 1 by 3, and so on till psi of, suppose you use n over here, or till n minus 1. Let's calculate till n minus 1, minus psi of n minus 1, 1 by n minus 1. Just add all these terms. What you will get? This and this will get cancelled, this and this will get cancelled, this and this will get cancelled, and this will also get cancelled, right? Okay, this is a telescopic series if you don't know. Okay, so from here you can say psi of n minus psi of 1 is the summation from I going from 1 to n minus 1 of I, of 1 upon I, correct? So we can say from a psi of n is psi of 1 plus summation from I is equal to 1 to n minus 1, 1 upon I, right? Okay, so you get the result psi of n is equal to psi of 1 plus summation from I is equal to 1 to n minus 1, 1 upon I, right? So let's erase this now and let's see how we can evaluate psi of 1. Okay, so remember what I defined? I defined psi of x as psi dash of x divided psi of x. Okay, now how can you evaluate this thing? Well, you all can think psi of x is the integral from 0 to infinity t raised to the power x minus 1 e to the power negative t dt, correct? So you can take its derivative, so it will be d by dx of the quantity 0 to infinity t raised to the power x minus 1 e to the power negative t dt. So you can bring it inside, it will be integral from 0 to infinity of the quantity del by del x t to the power x minus 1 e to the power negative t dt, correct? Now with respect to x, if you are differentiating, this is the partial derivative, so it will be equal to 0 to infinity t to the power x minus 1 e to the power negative t into ln t dt, correct? Because of course if you are differentiating with respect to x, t will be a constant. Do you remember or not? If you are differentiating it with respect to x, right? This is what you get. Okay. Okay. So just substitute x as 1. So you will get this integral 0 to infinity ln t e to the power negative t dt. So you have to evaluate this kind of integral. And I don't think so you are very much interested in finding the integral value of this function. But is there any other approach? Yeah, that's why I derived this thing. So let me tell you. And of course, if you have to find using this method also, you can use the definition that e to the power negative t is equal to limit as n tends towards infinity of the quantity 1 minus t by n whole raised to power n, and then you can solve it, okay, by using the limiting case. Okay, so this integral can help. Well, we can find the value of this integral using psi of 1. So let's see that now. Notice that notice that gamma of 1 will be equal to 0 factorial, which is equal to 1, right? So psi of 1 will be equal to the integral from 0 to infinity, this integral, right? ln t e to the power negative t dt. I think I should change the chalk because it's not visible, right? So okay. So we all know gamma of x is the limit as n tends towards infinity n to the power x n factorial divided by n plus x till x, correct? We have this expression. Now just take natural log both sides. Natural log of this quantity, limit as n tends towards infinity. Once you take the natural of both sides, this is a product. All these are in product, so you can apply the product rule. So you will have ln n raised to the power x plus ln n factorial plus ln this expression over here, right? Now notice that we can clearly break all this. Of course, this will be a negative sign over here, right? So it is limit as n tends towards infinity, natural log, we can bring x downwards, ln of n plus ln of n factorial minus natural log of n plus x till ln x, right? Okay. Now this was equal to natural log of gamma of x. Now just differentiate both sides. You will get psi of x then, right? The derivative of this will be psi of x. So it will be limit n tends towards infinity. This will become ln of n. This is a constant with respect to x, right? So this will be 0 minus, when you take its derivative, you will get 1 upon n plus x plus 1 upon n plus x minus 1 and so on till 1 upon x, correct? Okay. Now we have to find psi of 1. So psi of 1 will be equal to the limit as n tends towards infinity, ln of n minus the quantity 1 upon n plus 1 plus 1 upon n plus x minus 1 and so on, that is n, and so on till 1 upon 1, right? Okay. Now notice that this thing is what? This is actually 1 upon 1 plus 1 upon 2 till infinity, right? If you plug in infinity over there, right? So this is actually the negative times this limit as n tends towards infinity of the quantity summation as I goes from 1 to we can just bring the limits inside. So you can say it has the limit as I goes from 1 to infinity of the quantity 1 upon I minus the quantity integral from 0 to infinity 1 upon x dx. Correct? Sorry, from 1 to infinity. Notice that natural log of n can be written as 1 to t ln, sorry, 1 upon x dx is equal to ln of t. Correct? Okay. So this is what we are doing over here. And if you have watched my video regarding the Euler's constant, which I'll give in description, you all must be well acquainted that this is nothing but this is called the Euler's constant. So negative times the Euler's constant. This is Euler's constant gamma, where gamma is approximately 0.577. This is called the Euler's constant. Just check the video once. Okay. So psi of 1 is negative gamma. Okay, so now let's erase this. We have found the value. We have found the value, and we have found the value of this integral too, because it was equal to psi of 1. So this is equal to negative gamma, right? Okay, so let's erase this and let's find the general form over here. So we had got psi of x or n is equal to psi of 1 plus summation from I is equal to 1 to n minus 1 upon I, right? Okay. Now we have proved that this is equal to negative gamma, right? So psi of n is equal to negative gamma plus summation from I is equal to 1 to n minus I 1 upon I, right? So suppose if I ask you to find psi of 2, it will be equal to negative gamma plus summation from 1 to 2 minus 1, that is 1. So psi of 2 is equal to 1 minus gamma. Psi of 3 is equal to negative gamma plus 1 by 2, so it is equal to 3 by 2 minus gamma, right? So likewise you can find for any natural value over here. So this is the basic introduction of Digamma function, and I've discussed many things over here. So in the next videos I'll be telling you how to calculate Digamma function for real numbers. And one more thing, if I ask you to find the derivative of gamma at 1 or 2, how you will find it? Well, now it will be equal to psi of 2 times gamma at 2, which is 1 minus gamma, times 1 factor, which is equal to 1 minus gamma. If I ask you to find the derivative at 3, it will be equal to gamma at 3. So what is this? This is equal to 2 factorial times the quantity 3 by 2 minus gamma, which is 3 minus 2 gamma, right? And so on and so forth. So using this you can find the graph of the gamma function, and you can find the slopes at each point. Okay, of course this is for natural numbers. In some days I'll make a video regarding the real numbers, right? How we can find the derivative at real numbers, derivative for any value of input, right? So till then, bye bye, take care, and also that you learned something new from this video. If you did, then please do like, subscribe, and please support this video. Bye bye, take care.